Kalpana. I am very thankful to IEW for giving me the opportunity to chair the session on the this clean mobility innovation in clean mobility technology. And I am thankful for my presenters, Mr. Arun Krishnan, Mayank Bhardwaj, and Mr. Pranjal, who will come one by one and present their topic. And as we know that transportation sector is the one of the biggest emitter of the greenhouse gases, and there's an urgent requirement to decarbonize this sector. And currently, the electric vehicles are picking up in our country and now I hope that hydrogen and other alternate fuels like methanol, ammonia, and SAF will also pick up uh, to decarbonize this transport sector. So, first of all, I would like to welcome Mr. Arun Krishnan, Program Manager, Climate Policy Initiative, to present his topic.
Okay, hi. Um, this is technical conference, but the topic is not very technical, or at least it's not related to engineering. It is technical relation in relation to public policy, right? So, we are all going through this transition, the energy transition, the green transition, and there are certain people who are impacted by it, right? So the impact can be both positive and negative. So the positive impact will be areas such as battery manufacturing, um, powertrains, there is electric powertrains, and so on. So you require new skills, new manpower there. So those are the folks who benefit. But there are also people who do not benefit from this transition. Like for example, people who have expertise in IC engines, right? Now, even if they are working in the formal sector, like Tata Motors or something, you can reskill those workers in order to make them skilled in the electric powertrains. But think of the informal sector workers, okay, the roadside mechanics and so on, who are, you don't have a formal pathway for reskilling them, right? So a transition, green transition, you can see that there is economic development and growth, there is energy access and security, and there is environmental sustainability. These are three aspects you think of it technically, but also parallelly you should think of just transition, which means one is recognition, recognizing that there is a problem, there are parties who are impacted by it. Social inclusion in decision making. So governments, policymakers, and even industry need to include those who have been impacted by this in their decision making. Distribute burdens and benefits, right? So this is important. Um, so, there are certain burdens which also happen because of the green transition, right? For example, there might be, battery recycling. You will not dispose of batteries in the garbage dump or something, right? That's going to impact. That's going to create a social impact. That's going to create an environmental impact. So industry, government, etc., has to bring in regulations in order to recycle it or at least dispose it off safely, right? So the burdens and benefits of this transition has to be distributed properly. And finally, restore harm, right? So the transition, even though it is a green transition, there is some harm which might happen in some way. Maybe a new chemical which is used in future, you might find that, okay, it is more harmful for humans. Then you need to restore that to the previous condition. So when you consider all of these, in addition to the technical engineering aspects of the transition, that is just transition for you. I'm sorry. Yeah. Okay. So now let's look at. I think I missed a slide. Just give me a second. Yeah. Okay. So what are the top, changes which are happening, impacts which are happening because of the green transition, in mobility? First is electric mobility, battery storage systems. Then you have evolving value chains, right? So concurrent to this technical changes, value chains, supply chains are also evolving. Then there is digital transformation, and finally increasing policy intent and finance for innovation, right? So government is bringing in subsidies, government is bringing in policies in order to innovate in this sector. Yeah. Okay. So how do these changes translate into a just transition? So I've given for each of these trends which I mentioned earlier, what is the context, what is the impact on the transport system, and what is the consideration from a just transition perspective, right? Now, the context for electric mobility and battery system is that you see that globally EVs are increasing in number, and so is it in India. The prices of batteries have dropped and it is expected to drop even more. New battery chemistries are expected to come in line and therefore also decrease prices. The demand for battery is also going to increase, right? Demand for battery systems and so on. So what happens? What is the impact on the transport system? Okay, the impact is that there is a reduction in demand for fuel and increase in demand for clean electricity, right? And the second is economic opportunity for businesses. Now, the reduction in demand for fuel will directly translate into reduction in taxes collected by the government. You know that fuel taxes are amongst the one of the most buoyant and effervescent, I would say, sources of taxation for the government, and therefore the government, by using those fuel taxes, it may fund certain programs. Now, if the fuel sales itself goes down, then how do you make up for that, right? So that is a policy consideration which governments have to think about. And also, the other consideration is because of increasing industry, increasing production of EVs, you require new workers, you require reskilling, both in the formal and in the informal sector. And this reskilling has to be um, financed by the government and by businesses, right? So that is another consideration you have to keep in mind in the just transition. And finally, the disposal of hazardous battery waste, right? So the supply chain around that is evolving, but it needs to evolve further. So these are only some of the questions you can think about. There are more questions in the just transition aspect, but I'm just giving you a flavor of what to think about, from the audience is mostly composed of business and government. From a just transition perspective, these are some of the thoughts which you can begin with. Then when it comes to evolving value chain, EVs take less time to assemble. It is, in terms of complexity of components, it is simpler. There is a raw material component and material mining component there. So China, for example, or Japan, for that matter, they have locked in supplies of the materials which are required for batteries. Okay, so what are Indian firms doing in order to lock in that supply? And then there are new opportunities in terms of the ancillary industries as well, right? So what is the impact on the transport system? Increase in demand for certain elements like cobalt, etc. New business opportunities and shift in demand. So fuel, you have your HPCL, IOCL, everyone here. So what happens if the fuel of the future changes from petrol and diesel to flex fuels, to electric, to hydrogen and so on? So how is their business model going to evolve? And how are people who are dependent on it going to manage? So the government again and business has to think about the impact on all these players, and also the impact on the marginalized. So for example, if you look at the fuel station, there are other industries, not industries, I would say other retail shops, kirana stores, etc., which come up near fuel stations, boarding, lodging, etc., in highways, right? How are they going to be impacted when the fuel moves from petrol or diesel to battery electric? Because when you look at it, petrol or diesel, you can have fuel stations frequently on the highway. Whereas battery electric charging stations, the business model is such and the land requirement is such that you have to really plan out and space out their provision in highways, right? If that happens, what happens to businesses which are dependent on the fuel stations? Yeah. Now coming to the digital transformation, of course, there is more there is more AI, there is more application of IT in cars. If you look at a Tesla model, a lot of things which are done manually, analog in cars, has now become digital. And similarly, there are concepts around shared mobility, mobility as a service, etc., which are coming up, right? So because of that, what is happening? There is a more efficiency in transport, but also less demand for some forms of transport, right? Imagine that if there's a dynamic mobility as a service provision in a city, then maybe the demand for cabs, for auto rickshaws will go down, and so on, right? So, and also there is a change in the vehicle ownership model. People are now don't want to buy a second car, right? Or because you have Ola and Uber on tap, or even people are foregoing car ownership altogether because public transport system is improving, and so on. So these are the transport system impacts which are happening. So what is the just transition impact because of that? Again, maybe if there are less number of cabs on the road, then you have less demand for drivers. So what do you do with people who are jobless, right? Along with that, there is also a concern of um, gender and inclusion, right? So that's a whole other different topic which I'm not getting into right now. And finally, increasing policy intent and finance for innovation. So there are fiscal incentives like FAME 1, FAME 2 scheme, etc., which the government puts. And also there is a national mission on transformative mobility and so on, which the government has introduced. And because of that, there is a reduction in total cost of ownership in EVs, increase in EV adoption. You see that, after the FAME scheme took off, you really see an increase in EVs being owned by people, right? So here again, the government and the industry has to do some homework in terms of how they can really push. You don't want to give subsidies forever, but you want to kickstart the industry. So how do you really push demand for EVs and demand for electric mobility, and also equitable access for electric charging, right, across the highways, across different public spaces, and so on. So these all come under the just transition question in the electric mobility transition. Okay, so I wanted to talk about a project which we are doing currently. So we are working with the trucking sector. Okay, so trucking, as you know, accounts for the largest um, emissions in terms of transport, right? Medium duty trucks and heavy duty trucks, for example, they account for 45% of vehicular emissions in India. And the number of trucks is expected to grow 4x, right, by 2050. And of course, road freight accounts for 70% of India's freight. This can change, I mean, given the dedicated freight corridor, but still, road remains an important form of freight transport. Okay, so decarbonizing trucking is an important part of the puzzle. There are various manufacturers. In fact, I met Olectra today in one of the stalls who are working on this problem. So that is from the manufacturing side. And from the government side, perhaps, you can talk about extending the FAME 3 scheme if that happens to the electric trucking. But also you need to think about the induced and indirect jobs which are happening because of trucking, right? So what does that mean? These are the upstream and downstream jobs to truck logistics. So the upstream is the manufacturing, the various OEMs and their ancillary service and product providers, and downstream is the fuel stations, the aftermarket sales and service, as well as the informal sector service mechanics and so on. These are the indirect jobs. The induced jobs in the trucking sector are around various trucking clusters in India, truck laybys, ICDs, ports, agri-mandis, etc. You have a entire service sector which is dependent on the trucking economy. Okay, boarding, lodging, palletizing, kirana stores, retail shops which cater to it, and so on. So what happens to them as well when a transition happens from current fossil fuel dependent trucking to electric mobility, right? The problem is when formalization of the sector happens, right? Uh, Going forward, right now the trucking sector is extremely unorganized. But going forward, when formalization happens, okay, then you can find, and also concurrently, National Highways Authority is developing truck pit stops And Prime Minister Modi ji, I think day before yesterday, announced that the government is going to develop 1,000 truck stops across India. So there is more formalization of these truck stops. And in the West, if you see, there is an entire industry. There are companies which run these truck stops, right? So when that happens, then you find the informal sector workers being pushed out, and more formal sector retail, formal sector hospitality industry come into the picture. So what is the impact of this transition? How many people will gain jobs? How many people will lose jobs? And how much has the government has to spend in terms of subsidies, in terms of financial sops, etc., for the people who have lost their jobs because of this transition? So we are looking at it both at the formal sector level, that is the manufacturing, after sales service, etc., the informal sector level, that is the induced jobs around trucking clusters, as well as the informal sector mechanics and so on. So the study is ongoing. We still haven't got the results yet. But in terms of, because I almost run out of time, I'll skip this slide. But in terms of the policy interventions, this slide, although a little bit wordy, it gives you some of the interventions which the government can do, right? For example, you're looking at the actors here, and on the extreme right, you can see the actors who are responsible for alleviating or ameliorating that problem. Okay. Now let's look at, for example, public and private sector corporations, where you have a problem of financial risk due to declining EV sales, right? So there is declining EV sales, declining ICE sales. So let's say Tata Motors or something is confronted with this, or the industry as a whole is confronted with this. What do you do? What is the financial or policy intervention which the government can do in order to alleviate this? So of course you have the FAME scheme. Perhaps you can bring in a scheme to more incentivize charging stations, because that is one stumbling block when it comes to adopting electric vehicles among both fleet owners as well as the general public. So you can bring in policy interventions, financial interventions for that, and so on. So you can also come up with, for example, SIDBI has come up with a scheme with World Bank for providing credit guarantee for MSMEs to acquire electric vehicles, right? So credit guarantees, blended finance, any number of these innovative financial instruments you can think of which the government can introduce, right? So this slide really lays out, what are the issues which different actors can confront and what are the policy interventions which you can bring. Another issue is that, I spoke about the induced and indirect jobs which have been impacted. And I also mentioned that, if it is a company like car manufacturer, they have the wherewithal with some support from the government for reskilling their workers. But if it is an informal sector worker, informal sector mechanic, for example, how do you actually create the structure to reskill these workers, right? Maybe NSDC or Automotive Sector Skill Council can come up with the norms and a business model for private sector participants, and they can come up with a viability gap funding to set up these training centers across India. And you can say, you can invite mechanics, you can create these training programs in local languages, so that 1 or 2 days of training, and they're able to get the basics at least of how to repair an electric vehicle, right? So we need to think more along these lines in order to effect this transition, because it is not only a transition which is technical in nature. The technical part is the easy part, right?
Mr. Arun,
the financial part is the second.
please conclude
Yeah, almost done. The financial is the second most easy part, but I think the social and the economic and policy aspect is the most difficult part, which I think businesses and government should take care of. Thank you.
Thank you, Mr. Arun, for covering this very good topic. Now, next, I would like to invite Mr. Mayank Bhardwaj from RTI International to touch upon the sustainable public transportation, enabling transition through public financing.
Yeah, thank you. Arun talked about innovative instruments or financing instruments that are there. I'll try to cover one of them. Max there talked, so that I would be asking, people should be asking more of questions. So I'll try to cover up quickly and possibly, look if you have any questions. So I will, try and cover sustainable public transportation. Now, why sustainable? Why public? You know, why are we even talking about it? So, what is happening is that 14 out of the 15 cities, 14 cities are actually in India. They are tagged as the most polluted cities. Transport sector accounts for about 87% of the emissions and also about 20-25% of the PM 2.5 that is there. India, we all know, has a target of reaching net zero by 2070 and also has a target of reducing the emissions in the economic intensity by 45%. So in the backdrop of all these things, it becomes extremely crucial that the transportation is more public, or people should gravitate more towards public transportation, and the public transportation should become more sustainable or should have the sustainability aspect towards it. So if I talk about the sustainable public transportation, we know Indian Railways, right? They have already talked net zero by 2030. They are moving into the procurement of renewable energy, round the clock power. They're talking about electrification of their railway tracks. They're already deep into it. Now, when I talk about urban transportation, India is moving towards economic growth. There is a rapid urbanization of the cities that is happening, and there is also the economic growth perspective that is there. India remains prone to a lot of disasters that may happen because of climate change. Hence, it becomes again very crucial for us to look at this aspect. Now, if I talk about electric bus or urban transport in general, only about 0.3% of it is electric currently. There are about 22 lakh buses operating in the segment. We're talking about 35%. Emissions will become less considering the current power mix, which is about 15 to 20% renewables. And it will become about 87% less emissions if we make it a 100% renewable powered sustainable transportation. Again, there is a potential to move towards about 1300 tons of carbon dioxide equivalent reduction if people gravitate towards the public transport. So these are numbers possibly which, again, as I mentioned, will help in two things: achieving the net zero by 2070, achieving the 45% economic intensity by 2030. Now, electric bus. Now we've all spoken. We've all heard about it. What happens electric bus? Government has rolled out schemes. I think Arun also mentioned FAME 2, FAME 1. Everything is coming. But what is happening? So it is still like the tip of the iceberg, as I would call it. In Government of India, out of that 22 lakh buses, has come up with an ambitious program, and we still call it ambitious, of 50,000 buses by 2027. And still we are in a position that we are having the bids or deployment of only about 4,000 buses or 3,000 buses. In fact, today, the PM E-Bus Seva, the much celebrated scheme of the Prime Minister Modi himself, the only about 3,800 buses are actually going, the bid is being submitted today. So we need to scale up. And what the government has done, now they're actually talking about 8 lakh buses in the next 7 years. So it's a 16-fold jump that we are talking about. Again, huge investments. In the region of 8 to 9 lakh crore investment in the next 7 years only in the electric bus segment. But there are challenges. Now, what are the challenges? The counterparties, the state transport undertakings, the transport corporations of the different cities, they're not very as we call it, financially healthy, right? There are delays, there are payment delays, and there are long-term contracts of 10 to 12 years. That is first. Differential cost. So if I go to buy a diesel or a CNG bus versus an electric bus, there's a difference of about 4 times or 5 times. But if I look at the total cost of ownership over a life cycle of 10 years, I have it in the next slide. The electric bus will be about 20-25% cheaper at a overall ownership, as we call it, cost of ownership. Technology is still considered nascent. Uh, there are only 5 or 6 people in this business, right, including the manufacturers who can actually give you the electric bus. And the supply chain is very concentrated. We all know it's very concentrated. Most of it has to be imported. Government is moving towards the PLI schemes, but still it remains heavily concentrated. And there is one point there about type of financing, which I will try and address. That point is about how people can, how financing has a role to play in accelerating this deployment. Till the time I am limited by the strength of my financials, the strength of my balance sheet, as we call it, it's really not going to scale up, which is one of the major reasons what we're seeing. It somewhere it has to move towards the strength of the project, the strength of the cash flows, the strength of the initiatives. Uh, so, how we can actually enable that transition, as we call it, towards project finance? I have a couple of slides on what we have done and what can be done and what the government is doing, and I'll cover that. So that will remains primarily the topic. Now, if I look at it, why? So there's a payment security mechanism. I will try and cover here it, which is important for a project finance perspective. Now, why it is crucial? It is crucial because the banks, being as conservative as they are, they look at the counterparty risk, they look at the nature of the contract, they look at the technology, and what is happening here is that there is a low credibility of the counterparties. So if we talk about the state transport undertakings, their revenue sources are very limited. They really don't have the collection to pay off the what we call the obligations under the contract when it happens. So the banks are not ready to willing or not willing to actually come in and give money to the players. Now, if the banks don't come in, what starts to happen is you raise money on your own balance sheet, and again we get into the same issue again. So that's why it becomes very crucial to have some sort of a payment security mechanism, some sort of a comfort for the lenders actually to come in, so that the project finance and the scalability for the electric bus can be done. Now, how it's going to happen? So, renewable energy. I've just taken a case study from what the government did in renewable energy. Solar Energy Corporation of India, that entity came in. They were put in between the distribution companies and the solar power developers. So they had the two contract structure, wherein they signed the power purchase agreements with the solar power developers and they signed the power sale agreements with the distribution companies, and in a way they took the risk of payment default or payment delays which the distribution companies were making. That payment security mechanism came in about 2016 and 17, and we have seen a 4 to 5 fold jump in the renewable energy sector, especially when it talks about investment, especially when we talk about the capacity that has gone in. So from a 3 to 4 gigawatt, we are now talking about 12 to 15 gigawatt sort of a thing. And that is one of the reasons is this payment security mechanism which came in. Now, how it operates is that there is a security fund, a payment security fund that was created by the government through its budget. It was about 500 crores and now it has reached a level of 1500 crores. In case there is delay by the distribution companies in making payments, the payment security fund gets triggered, the money flows to SECI and then pays the money to the developers using the payment security fund. Now, and as soon as the distribution companies pay back the money, the fund gets recouped again to its original level. Now, what happens if the discoms still don't pay? So if the delays continue beyond 6 months, what happens is that there is a tripartite agreement between the central government, the state government, and the RBI. the SECI uses that agreement, triggers that tripartite agreement, and actually RBI deducts the state account directly and pays SECI, which again can be used to, pay the developers or to recoup the fund. Now, because of this direct debit, or we can call the tripartite agreement, it becomes very, in a way, prohibits such payment delay or payment default behavior of the entities. Now, when I come to electric buses, what we did, we studied this mechanism and we made some changes. Now, what happens here is that this can also be done through a scheme, a government of India scheme that can come in. We are not really looking at having a counterparty or a government entity in between to sign the agreements. We're looking at a entity to actually facilitate the scheme, because if a government entity enters into such a scheme, it becomes, contractually obliged to make the payments. So we have, moved away from that concept. It's primarily that we're looking at agreement from the state for a direct debit. And what happens is that why the states will do it, because there are certain incentives that come with this direct debit mechanism. So a lot of schemes on the electric bus actually come in. The demand aggregation, the per kilometer subsidy or the operational subsidy comes in, and that's why the states, it's a win-win for the state. Then again, there is a payment security fund here, which I'll show in the next slide how it's getting funded. There's a concession agreement between the state transport corporations and the operators, and again, the similar mechanism will flow that if the default persists for more than 30 days after the due date, the government entity can actually use this payment security fund to give money to the OEMs or the operators, as we call it. And once the money is recouped or it's come back, the payment security fund can actually be recouped back to its original state. Now, and here we have kept the duration as 90 days instead of the 6 months that was initially there, primarily for the reason because we are looking to maybe fund a larger number of buses here, and also because of the condition of the state transport undertakings at the moment. So a 3-month sort of a fund, 3-month support shall be given or shall be available through this fund. Now, if I come to the fund structure, as we say, so here we are looking at possibly the fund to be created through some of the sovereigns and some of the philanthropies. So recently you might have also heard about the US-India collaboration, which specifically talks about this, this initiative of payment security mechanism for Make in India electric bus. So under this scheme, there will be certain contributions that will come from the government of US, certain budgetary allocations that will come from the government of India, and the fund is created. And we are looking at, I talked about in the SECI case, the initial size of the fund was 500 crores. Here the size of the fund will be around 4,000 crores. And this 4,000 crore fund is sufficient only for about 38,000 buses. And we are still talking about the 8 lakh buses that I mentioned. So we can see how this market is evolving and where actually this payment security mechanism becomes crucial, because once it gets triggered, once we're able to use this to deploy about 50,000 buses in India, then only we can actually talk about, then only the bankers will become more conversant, more comfortable with the project finance structures that they are now, for example, in the renewable energy space, and start to fund the electric bus space as well. So this is just my last slide. As I mentioned, the benefits. First, the banks will come in. And in case the banks come in, it becomes the private sector from an equity side also gets interested once the risk starts to reduce. So de-risking, as we call it, the de-risking will happen. More private sector players will come in. And hence, we ultimately, the final, what we call the rates, the gross cost contract, the GCC have mentioned, the per kilometer rates that are quoted will actually go down. Again, I talked about the 38,000 buses the PSM will support. Talks about a $10 billion opportunity. But this is just the start. We have to keep that 8 lakh crore opportunity in mind when we move ahead. So that's it. That's it from mine. I'll be happy to take any questions if there are any.
Thank you, Mayank, for covering the touching upon the public financing on the mobility. Next, I would like to call Miss Pranjal Jejukar from IIT Mumbai to present her topic.
Good afternoon, everyone. I'm Pranjal. So, my work is entailed with harnessing wind energy for electric vehicle transmission and vehicular public transport system. So, yeah, this is the overview of my presentation. So, I'll start with the introduction. So starting from the Paris Agreement, which is Paris 2015, we all know sustainability. Nowadays, we are talking a lot about sustainability, but nobody actually knows what is sustainable development. So it was also presented in the Brundtland report that sustainable development means meeting the requirements of the present, which is existent economy, and also planning or sort of storing for the future generations. So there are. Thank you so much. Hello. Yeah. Thank you. Uh, as we know, there are 17 SDGs, which is the Sustainable Development Goals, and my work will be currently focusing on SDG 7 and 13, which is mostly about affordable and clean energy and the climate action. So, as we all know, the Kyoto Protocol was set up. After that, which Conference of Party 28 was followed, and each and every countries they are curtained to perform under some criteria, which has to be around 1.5 degrees Celsius of a less greenhouse gas emissions as compared to the other countries. So, focusing on that, COP28, my work entails about the vehicular transmission pollution and how to harness wind energy in order to meet the charging demand. So I'll present the methodology. So the planned city is Navi Mumbai. So it has a satellite. It is a planned. It is a planned city where it is located in the Konkan division of Maharashtra. It covers an area of about 344 square kilometers, out of which only 163 square kilometer falls under the purview of the Navi Mumbai Municipal Corporation. So the geographical extent, which is 19 degrees 1 minute 14 seconds latitude north, and simultaneously 73 degrees 36 minutes east longitude. The current population estimate as on around on 2024 is 1,000. Yeah, it is 15 lakhs 89,000. So now coming to the air quality statistics and the data, which about the vehicular traffic or vehicular emissions, is as you can see. Yeah. So the location-wise data, these are the major locations in my study. I have focused on Belapur, Nerul, Vashi, Turbhe. So as you can see, the standards of each area and RSPM, which is the respirable suspended particulate matter and the total suspended particulate matter, the SOx, NOx, and carbon monoxide emissions. So as you can see, the Navi Mumbai metro line, it is planned in 3 stages, which is phase 1, phase 2, phase 3, but currently only phase 1 is operational. So the rapid transit, which is phase 1, is around following an average speed of 60 kilometers per hour, which makes 37 miles per hour. The top speed reached is 90 kilometers per hour and 23.40 kilometers miles. It consists of 20 stations. So the phase 1, which comprises of 11 stations, it falls and it covers a distance of 11.10 kilometers, and it is operational since November 2023. So as you can see, the Navi Mumbai metro line goes from CBD Belapur to the destination, and just so the growth rate, I've tried to calculate the by incremental method the growth rate from the past 8 years, which is from 2009-10 to 2016-17. Now, the total numbers of vehicle registered, this data was, I acquired this data from the government sites, the RTO, and the average traffic growth came around 12.82%. So the traffic growth rate also estimated for different vehicle types. So specifically, my research deals with two-wheeler, three-wheelers, and four-wheelers, as we are talking about electrifying the vehicles. So the growth rate varies from about 9 to 20% based on the RTO data. So as you can see, two-wheelers given for 13.43%, three-wheelers for 9.27%, and four-wheelers for 20%. Now, talking about the charging demand required by these each vehicular segments. So for two-wheelers, the numbers as you can see over the screen, the average growth rate presented from 9 to 20%, and the estimated traffic by 2030 year. So, which also there are many EV policies which say about as presented in before, 80% of EV has to be electrified in the coming the buses, the two wheelers, four wheelers. Every vehicular segment has a slab in which they need to complete. So, by the number of electric vehicles targeted by Government of India, 80 for two vehicles, 80% for three wheelers, and simultaneously 30% for four wheelers. Now, these are the battery specifications for different types of electric vehicles, which falls under 1.2 to 3.2 kilowatt hours, 3.6 to 8, 30 to 80% respectively. Now, the main picture is here about the total daily charging demand. So, per day, what we can calculate for per vehicle, and hence how to combat or how to manage that charging demand by the renewable energy technologies and not from the power grid, which is coal based. So as you can see, the daily drive for all the three vehicular segments being 40 kilometers, the battery capacity for each, and the driving range in full charge. Now talking about the daily charging demand per vehicle wise, we get 1.25 kilowatt hours, and the total daily charging demand based on the number of registered vehicles in 2030. So the total charging demand comes around 3 crore 62 lakhs 85,973. Now focusing on the vertical axis wind turbine. Now, how to harness energy in order to combat or in order to manage the load which was calculated from the charging demand, to be calculated from the charging demand. So, vertical axis wind turbine, this is, we are trying to harness wind in order to combat the load. So, why vertical axis wind turbine, first of all? So, as we know, horizontal axis wind turbine occupies a lot of space. It is a bulkier instrument to install, and also it needs a lot of equipments or a lot of connections and transmission lines to focus. Now, vertical axis wind turbines, the baseline of electing vertical axis turbine was it can also work in low wind speeds, which also means it can be installed during in the metro line between two stations, and it can harness the very minimum low speeds. So it also has less noise during operation. It is very economical and simple and easy to design, and even the maintenance cost is low. Also, it is economical in a way where the yaw mechanism, which means the portability factor and the space it occupies. So it can be placed near ground surface. Now there are different types of vertical axis wind turbines. We have 7 years modern, which modern horizontal axis wind turbine. So as you can see, the size of the pole, the size of hub or hub diameter, we can say it is very slender, and it needs a higher location, and it needs around 10 meters of height at least. So hence we are not going for the horizontal axis wind turbine. We have also Giromile or Darius wind vertical axis wind turbine. So now 7 years axis vertical axis wind turbine, it has 3 blades in a spherical or a concave form, and these type of blades acquire maximum power for the power equation, which I'll be discussing in the coming slides. Now talking about the weather conditions for harnessing wind energy. Now as you can see, in summer and winter, the wind data, which is the wind pattern, is as follows. In summer, all the wind intensity comes towards the middle part, and hence in winter so in the seasonal variation average wind velocity at metro stations. So the average wind speed for Navi Mumbai based on the annual wind pattern studies for year 2023 was calculated by a Meteor Blue, which is a website where you can calculate the wind pattern where you can get maximum and minimum wind speeds in that particular area, basically the intensity of wind for in order to harness. The simulation history archive source from the Meteor Blue first commercial weather service worldwide to regularly publish the verified data and daily local accuracy updates. So this was the data from a month, that is 31 month of 31 days, which is January, February, and similarly till December. So the cumulative wind speed data from the month of January to December 2023, and as you can see the highest and the lowest ranges and also the average wind speed data. So we can see in June and October we have the highest wind speed data, and in the lowest we have the minimum and maximum of the lowest wind speed data as well. So the lowest wind speed data comes around 1.8 meter per second, and the highest wind speed comes around 5.5 meter per second. So the average wind speed calculated from it comes around 3.7. Now for designing the wind axis turbine, which is Savigny's turbine, for harnessing or combating this load, what we did is we tried to find out the net wind speed in 4 different combinations, taking the highest and the lowest wind speed data. 16 plus 1.8 meter per second gives 17.8 meter per second. Similarly, you can see the calculations, and hence the net average wind speed was calculated around 16 meter per second. So the cut-in speed, which is 0.5 times of 16, is 8 meter per second, and cut-out speed 48. So the turbine, the vertical axis turbine is designed to carry out the load. The rated average wind speed comes around 1.5, which is the rated, it is already specified for the turbine, which is 1.5 times of 16 meter per second, which is 24. Now the design of the proposed Savigny's vertical axis wind turbine, it is taken from Khandagel et al. 2017 prototype to generate 50 watts of power. As I told about the power equation, so we have Cp, which is the coefficient of performance, coefficient of power divided by 2 into rho AV cube. So the number of blades, so as you can see in this on the screen, it is a typical vertical axis wind turbine, but we have designed it for 4 blades. So as you can see, the DO being the outer diameter, DI being the inner diameter, and small e being the hub diameter, along with height. So to calculate the load, or to accommodate the design with respect to our locations for the metro line. So to accommodate the design with respect to the location constraints, the diameter, D, and height of the turbine are limited to 1 and 1.5 meters respectively. Therefore, calculating for the area is diameter into height, which is 1.5 meters square. Now, as we got the power as 1.20 kilowatts. Now, assuming the parallel quad, so as we know, metro line, one is a going journey and one is a return journey. So between 2 stations, as we know, these turbines can also work with lower speeds. So hence, the installation of such turbines at a distance where the maximum power can be harnessed. So it comes from the moving train, which is 1.2 kilowatts into 8. So if we place 4 turbines at each return journey plus so it comprises 8 turbines. Now, so this is the design which we have proposed for 4 blades. And so as we are talking about sustainability, composite materials such as carbon fibers are used to manufacture the turbine blades. So it has a high stiffness, low density, long fatigue life, and which is proposed for the vertical axis wind turbine. Hence, even it will be economical. Now, talking about economical, each vertical axis wind turbine cost about 75,000 to 1 lakhs, which is pretty much affordable, and it can give the output as well. Now, talking about for parallel quad vertical axis wind turbine, between two metro stations where the train speed will be maximum, running at 8 meter. As one train, the frequency time between first and the other is 8 minutes. So, assuming for if the metro line runs around 17 hours a day, which is from 6:30 morning to 11:30 evening, which makes 17 hours. So, calculating for 60% output. Now, why 60% output? As the rest of the 40%, which is not calculated, it could be transmission losses, could be location optimization, and so forth. So hence 60% of the output is considered here. So at one metro station, if we calculate for 17 hours by 8, as you can see, 1,469 kilowatt hours for all the 11 metro stations at 10 locations. And see the total energy generated could be 14,690 kilowatt hours. So based on the daily charging demand of electric vehicles, 1,175 two-wheelers, 175 three-wheelers, and 367 four-wheelers can be charged at only one metro station. So we have such 10 metro stations, 11 metro stations. So based on the daily charging demand of EVs, the numbers, as you can see, we can charge numbers of 2, 3, and 4-wheelers. It can be charged at total 11 at a stretch of 11 operational metro stations of Navi Mumbai Metro Line 1. So these are the proposed red data points represents the location of the vertical axis wind turbine. So for 11 stations, we can have 10 such locations. Concluding my study, the implementation of parallel quad vertical axis wind turbine between two metro stations for Navi Mumbai Metro Line 1 operating at 8-minute intervals for 17 hours a day, it has demonstrated a significant energy generation with a conservative estimate of 60% generated at one metro station amounts 1,469 kilowatt hours, and when extrapolated on 7 metro stations, the cumulative energy generating reaches an impressive 14,690 kilowatt hours. So the same data as I presented in my discussion slide, so it reveals that the capability of charging a substantial fleet of 117,750 two-wheelers, 1,750 three-wheelers, and 3,650 four-wheelers is sustainable. Now, these findings not only underscore the viability of integrating wind energy solutions, but also the urban transit systems, and emphasize the significant impact such as initiatives can have on the assessing the, and it is also a rapidly advancing electric vehicle ecosystem or infrastructure. The combination Now, this combination of renewable energy integration basically, it, where the charging infrastructure presents a forward-thinking approach to foster sustainability and hence reducing carbon emissions in a metropolitan city. So this way, the wind harnessing can be done by the metro line, and hence incorporating or installing the vertical axis wind turbine, the charging demand can be met, and hence it could be sustainable. These are my references which I used in my research, and thank you.
Thank you, Pranjal, for covering this very good topic to produce this electric energy locally and then use it as a locally. So it will be as good as the decentralized model, so which is very good for countries like India, where we can produce electricity. Same is applicable for biomass also, where we can produce the biofuels locally and consume locally. So I am very, I appreciate your topic very much, and I think India should focus on the decentralized model for new molecules like hydrogen, electric vehicles, or biomass. Thank you, and I also thankful to Arun and Mayank for touching upon the financing part. So I hope all will be benefited by the topics which are presented by the presenters. Thank you very much for attending the session. Thank you.